Hey, welcome everybody. This is Mr. Gannon, and in this video we're going to take a look at the 4.3 notes in Algebra 2, where we're going to solve a quadratics using square roots. Now, this is something that we did do at the end of Chapter 3, so it might look familiar to you, and if it does, that's a good thing. But let's go ahead and get started with a couple basic examples. So, if we look at number 1, when we are solving quadratics, the first thing we have to do is get the quadratic term by itself. So we want to isolate either the x squared or the binomial squared. So I'm going to kind of write that down as step 1. We're going to isolate x squared or binomial squared. So for number 1, that's going to imply subtracting 25 from both sides. So x squared is equal to negative 25. At that point, we're going to move on to step 2, and we're going to square root both sides. So we square root here, we square root here. On the left side, we get x, and then on the right side, we've got a negative under the square root, which implies we're going to take out the I. And then the square root of 25 we know is 5, so we're going to go ahead and put 5i, and we can't forget to put plus or minus in front. So the answer there is x equals plus or minus 5i. There is potentially a third step when we're doing this, and that third step would be to isolate x, which is going to happen anytime you have a binomial squared. All right, if we take a look at number 2, I'd encourage you guys to pause the video, try the rest of these on your own, and then go back and watch the video and see how you did. So for number 2, the thing we want to isolate in this case is x squared right here. So in order to do that, we're going to add 30 first. So we've got negative 3x squared. We're going to add 30 to get 36. We still have to get x squared alone. To do that, we're going to divide by negative 3. So 36 divided by negative 3 is negative 12. All right, now that we've isolated x squared, we're going to square root both sides. All right, now for this, 12 is not a perfect square, but it is a radical that's going to break down. So I'm going to do a little side work. A negative underneath means we can rip out the I. So we got I root 12. 12 can be broken down as 2 times 6, and then 6 becomes 2 times 3. So there's our pair of 2's and a 3 left over. So we're going to come back over here, and the final answer is going to become 2i radical 3. And then we have to remember to include plus minus because we are solving by square rooting. Okay. All right, if we look at number 3, all right, this time we have to get the binomial squared by itself. In order to do that, we're going to add 9 to both sides. So we got x minus 2 quantity squared equals 9. All right, we've isolated the binomial squared, so we're going to go ahead and square root both sides. On the left side, we have x minus 2. On the right side, the square root of 9 is 3, but we have to include plus minus. Now, this is a situation where we want to get x by itself. So to do that, we're going to add 2 to both sides. So adding 2 is going to become 2 plus or minus 3. Now, this case, we have like terms, so we're going to go ahead and do both of those. This is 2 different answers. One of them is 2 minus 3, and the other is 2 plus 3. So 2 minus 3 is negative 1. 2 plus 3 is 5. That becomes our 2 answers. All right, and then over here with number 4, we're going to isolate the binomial squared. To do that this time, we're going to get rid of the 1/4 by multiplying both sides of the equation by 4. So they're going to cancel here. That's going to leave us with y minus 6 quantity squared, and then 8 times 4 is 32. We can now square root both sides. Y minus 6 is on the left, and then we're going to do some side work again with the square root of 32. If we break this down, we can do 2 times 16, and then 16 is a perfect square. That's 4 times 4. So we can go ahead and rewrite that as 4 radical 2, because the 2 doesn't have a partner. Don't forget your plus or minus. And then we have another situation where we have to get the y by itself. We can do that by adding 6 to both sides. So that's positive 6 plus or minus 4 radical 2. This time, we do not have like terms, so we go ahead and leave our answer just like this. All right, so that's 4 examples of solving quadratics by square rooting. Now, we want to take that idea that we did in chapter 3 and tie it into the graphs of these quadratics. So when we solve quadratics, we can have no solution, we can have 1 solution, or we can have 2 solutions. Now, there's really a word missing here. We should really say no real solution. 1 real solution, 2 real solutions, because those are different things. So, when a quadratic has no real solutions, the graph is going to look something like this. You're going to have a vertex, and the parabola would open up away from the x-axis here. If there's 1 real solution, you're going to have a vertex that is on the x-axis, and the parabola could open up, or it could open down from that point. If there are 2 real solutions, you might have a vertex that's below the x-axis, and the parabola could open up. Now, the solutions are the x-intercepts of the graph. So here would be 1 solution. Here we would have 1 solution here and 1 solution here for 2 solutions. So you got 2 solutions, 1 solution, and no solution. So the connection between the solutions and the graph are the solutions of the equation are the x-intercepts of the graph. So you might want to make a note there. The solutions of the equation are the x-intercepts of the graph. All right. So a lot of that is tying into, previous prior knowledge to what we did. So now let's get into the type of problems we've been working in chapter 4, which are quadratics. So, the notes say here, now that we can change a quadratic function from standard form to vertex form, we can easily find the vertex. In order to find the solutions, which actually has 4 words that mean the same thing, so solutions, roots, x-intercepts, and zeros, all we need to do is solve by using square roots. All right, so what we're going to have to do is take what we've done in the previous units and rewrite our given equation that's in standard form into vertex form. We're going to do that by completing the square, okay? And that's what it's asking us to do. Oops. Sorry, that's what it's asking us to do right here is rewrite it in vertex form, which remember is y equals a x minus h quantity squared plus k. So the process that we've used to do that is called completing the square. We're going to start by grouping the x squared and the x term. If there is anything in front of x squared, you factor it out. We don't have anything, so we're going to go ahead and rewrite the x squared, the minus 8x. We're going to leave a space inside the parentheses, and the minus 33 goes on the outside. Now, to complete the square, we're going to add something inside and then subtract something outside. The value that we add on the inside, you take the middle number, in this case -8, you divide it by 2, and you square it. Well, -8 divided by 2 is -4. -4 squared is positive 16. So we're going to add 16 here. We're going to subtract 16 here. If there was a number in front that we had to factor out, the 16 that we subtract would be multiplied by that number. That doesn't happen here. So now we're ready to factor. All right, the purpose of completing the square is to create a binomial squared. What goes in the parentheses will be x, and then half of that middle number, in this case -4. We've got -33 minus 16, that's -49. So that would be the first step in this problem, is the vertex form. Now, once you have the vertex form of the equation, you could answer a lot of questions. You could identify the transformations. You could graph the function. you could do domain, you can do range, all those things we've been doing. But kind of the new element in this lesson is finding the x-intercepts. So to find the x-intercepts, set y equal to 0. So we take the equation, we're going to put 0 where the y was, and then now we're going to have this equation, x minus 4 quantity squared minus 49. Now we can go ahead and solve this by square rooting. So we want to get this by itself. That means add 49 to both sides. X minus 4 quantity squared. We can now square root both sides. The square root of 49 is 7. Don't forget plus minus. And then x minus 4 is on the right. Now we still have to get the x by itself. We can do that by adding 4 to both sides. So that's going to be positive 4 plus or minus 7. Now, these are like terms. So we're going to get two separate answers. 4 minus 7 and x equals 4 plus 7. So 4 minus 7 is negative 3. 4 plus 7 is 11. These solutions are the x-intercepts. Okay, so those become the x-intercepts of the graph. So now, how we can tie all this together with things that we've already been doing is we can use the vertex form to sketch the graph. So when you're looking at the vertex form, x minus 4 is telling us to move the graph right 4. Minus 49 is telling us to go down 49. Well, if we sketch, we're going to go right, down, and our graph is going to open up like this. We could label this point as 4, negative 49. Not sure what happened to my, sorry, this was down 49. All right, this point would be one of the x-intercepts. In this case, that's going to be negative 3 comma 0. This point would be the other x-intercept, 11, 0. Now, there's obviously different things we can identify. We could figure out, we could find the y-intercept, we could find the domain, the range, and all those things. But for now, we're just going to stick to that element. All right, next example. Okay, so this is going to ask us to find a few different things, so we can do that once we get the graph. So when we're solving, the first thing we're going to do is rewrite it in vertex form, like the directions say. So the process for doing that is completing the square. So we're going to go ahead and we're going to group the first two. In this case, we have a negative in front of the x squared, so we factor it out. So that means that inside the parentheses, the x squared is now positive. The negative 2x becomes positive 2x. We have a plus 3 on the outside. All right, we're always going to add inside, subtract outside. The number that you add is half of the middle, so half of 2 is 1 squared. 1 squared is still 1. So we're going to subtract 1, but then the 1 that we subtract is going to get multiplied by the negative 1 that we took out in the front, right there. So it's just kind of be aware that this is where this is coming from. Now we can factor. Y equals, you have a negative, you have a binomial squared, which this time is x plus 1, and then 3 minus 1 times negative 1 becomes 3 plus 1, so positive 4. Okay. There is your vertex form. From there, it does say to graph completely, which implies we want x-intercepts, y-intercepts, all those things. So in order to solve this, we're going to set y equal to 0. We've got negative x plus 1 quantity squared plus 4. We're going to go ahead and solve by subtracting 4. And again, the idea is we're trying to get this by itself. So it's not by itself yet. We can get it alone by getting rid of the negative, either divide by negative 1 or multiply. Either way, you get 4 equals x plus 1 quantity squared. We can square root both sides. The square root of 4 is 2. Don't forget plus or minus equals x plus 1. We want to get the x alone. And in order to do that, we're going to subtract 1. So x will be -1 plus or minus 2. Now, from here, you're going to get two answers. -1 minus 2, -3. -1 plus 2, 1. Okay. All right. So obviously we have a lot of things going on at this point. Some of the things to make sure you understand is vertex form is what I meant to write here. Sorry about that. And then these values that we just found right here, these are the x-intercepts, but they are also called solutions, roots, zeros. Anytime you see one of those four words, you solve the exact same way. All right, so now if we go back and answer the rest of these questions, I would always start with the transformations. So to get the transformations, we're going to use our vertex form right up here. The negative in front is a reflection. The x plus 1 is telling us to go left 1. The plus 4 is telling us to go up 4. Now, in this example, we're dealing with relatively small numbers. So if I just scaled out the graph, so 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All right, we could scale out the graph, we could plot these points. So if I'm going to plot left 1 up 4 from 0, 0, I'm going to go left 1 up 4, put a point. Now, normally parabolas go over 1 up 1, over 2 up 4. The reflection is going to tell me to go over 1 down 1. So over 1 down 1 is going to put me here. Over 1 down 1 to the left is going to put me here. If I go back to the vertex and I go over 2, I'm going to go down 4, which is going to put me here. Over 2 to the left, down 4 is going to put me here. And my graph will look like this. Okay. And then from this graph, I can answer all the other questions. So the vertex, left 1 up 4, that's going to be -1, positive 4. The domain, that is all real numbers. Okay. The min or max, well, this point, the vertex is the highest point, so it's a maximum at 4. The solutions, right? The solutions are the x-intercepts. Solutions. Those are these numbers right here. So we're going to simply say that x is equal to -3 and 1. And if you look at the graph, here's -3, here's 1, which we were able to come up with graphically even if we weren't able to solve that equation. The range in this case is y is less than or equal to 4. Because the highest point is the vertex at 4, it's everything below 4. Now, for the y-intercept, we always have an x value of 0. And if we look at the graph, this point is our y-intercept, which is at 3. Okay. Now, the other way to identify the y-intercept is by plugging in 0 for x. And if you were to do it to either of these equations, you would come up with y equals 3. The shortcut, if you understand it, is always going to come from right here. This value, c in standard form, will always be the y-intercept. So if you know that, it's a little bit of a shortcut. Okay? But it's got to be standard form. All right. A couple more examples. So for number 3, we're going to do the same thing. We want to start by rewriting the equation into vertex form. We do that by completing the square. So we're going to group those together. Nothing is in front of the x squared, so we just leave it alone. The plus 9 goes outside. We add inside, we subtract outside. The number you add, half of 6 squared. So half of 6 is 3. 3 squared, 9. If we add 9 here, we subtract 9 here. When you go to factor, you have a binomial squared from the parentheses. In this case, it's x plus 3. 9 minus 9 is 0, so we're not going to have anything there. That becomes the vertex form. if we are solving this, so if we're going to solve, we would set 0 equals x plus 3 squared. You've already isolated this so you can square root both sides. The square root of 0 is 0. X plus 3. You would solve by subtracting 3, so x equals negative 3. All right, so our transformations in this example are going to come from the x plus 3, which is left 3. And that's it. It's the only thing happening. So again, we're dealing with small numbers. Let's go ahead and mark the graph out, just so we don't have to label every single point. So in order to graph this, we're going to start left 3, put our point. It's a positive parabola, so we're going to go over 1, up 1 on both sides. We're going to go over 2, up 4 on both sides. And our parabola is going to open up. The vertex, negative 3, 0. The domain, all real numbers. This time the graph has a minimum at 0. The solutions, right, are coming from here, which is negative 3. That is also the x-intercept. The range, y is greater than or equal to 0, and the y-intercept would be 0, comma. Now, this time when you look at the graph, you're not able to identify exactly what the y-intercept is unless you extended the graph. But in standard form, this value is your y-intercept. So if you know that, it makes it easy to answer 0, 9. If not, you could always plug in 0 to either format. 0 plus 3 is 3. 3 squared is 9. So it's going to work both ways. Okay, on the next page. So here we've got some word problems. And what we're going to try to do is figure out how do we use the ideas or the concepts that we've talked about to answer these questions. So in this problem, for example, for a football is kicked in the air. Its path can be modeled by the equation f of x, negative 16, x minus 5 quantity squared plus 21, where x is the horizontal distance in feet and f of x is the height. What is the maximum height of the football? So this is not something that we've talked explicitly about, but if you look at this equation, this is vertex form. There's a negative, which implies that the parabola is opening down. So we're talking about a parabola that looks like this. The word maximum, well, we've been talking about max and mins. In this case, the point here, which is our vertex, is going to be our maximum. The transformations are going to tell you that the coordinate is right 5, up 21. So 5, 21. This value right here is our maximum, okay? So the max height is 21 feet. And I know it's feet because the problem told us the units were in feet. So the maximum height of the football is 21 feet. All right, example 5. A rocket is launched off a platform with an initial velocity of 19.6 meters per second. The path of the rocket can be modeled by the equation h equals negative 4.9 times t minus 2 quantity squared plus 78.4, where h is the height of the rocket and t is the time in seconds. What is the maximum height of the rocket? This is pretty much the same question as before, right? A negative parabola is going to open like this. The maximum is going to happen at the vertex. This time the coordinates are going to be right 2, so positive 2, up 78.4. So the max height is going to be 78.4. The units this time are going to be in meters. All right. Now the next question says, after how many seconds will the rocket hit the ground? Now this question is a little different. So we want to know, when is the rocket going to hit the ground? Well, if we drew an x and a y axis, the ground would imply that the height of the rocket is 0 at those places. okay? So what we can do is basically solve the equation like we did for x-intercepts. 0 equals negative 4.9 t minus 2 quantity squared plus 78.4. Okay. It's in vertex form. We can always solve these equations by square rooting. So we're going to go ahead and isolate the binomial squared. That means subtract 78.4. Got negative 4.9 t minus 2 squared. Still need to isolate this, so we can go ahead and divide by negative 4.9. And if we do that, so negative 78.4 divided by negative 4.9 on a calculator is going to give us 16, which is definitely going to be a nice number when square rooting. All right, now we can square root both sides. Square root of 16 is 4. Don't forget plus minus. This is t minus 2. And then in order for us to get the t by itself, we have to add 2 to both sides. So t is going to be positive 2 plus or minus 4, which is going to give us 2 answers. 2 minus 4 is negative 2. 2 plus 4 is 6. So our time is either going to happen at negative 2 or 6. Well, one of these doesn't make any sense because negative 2 would imply 2 seconds before the rocket was even launched, because t equals 0 would be the moment the rocket was launched. All right, so the rocket will hit the ground after 6 seconds. All right, so that's how we can take and apply these ideas we've been doing into word problems. All right, I think it's the last example. Let me verify that. Sorry. Yes, I hit the wrong page. Okay, so the last example, I was like, so it says, given the function f of x is equal to x squared plus 2x plus 7, state whether the parabola opens up or down, and the maximum or minimum. What do you need in order to find the maximum or minimum? So the given equation is in standard form. Because it is a positive equation, we would know that the parabola would open up. Okay? So without it being in standard form, we do know the parabola opens up. So we could answer that part of the question. We do know when it opens up, it has a minimum. We can answer that question. But what we don't know is what is the minimum value. So what we need in order to find the maximum or minimum, we need the vertex. Okay, so to answer this question right here, we need to know the vertex. And the way that we're going to find the vertex is completing the square, just like we've had to do on many of these other questions. So we group the first 2 terms. So f of x is, there's nothing in front of x squared. So we got x squared plus 2x, leave a space, plus 7. Half of 2 is 1, 1 squared is 1, so we're going to add 1 here, we're going to subtract 1 here. And then this is going to factor into a binomial squared, which is x plus 1. 7 minus 1 becomes positive 6. So this is what the equation would look like in vertex form. All right, the transformations are telling us left 1, up 6, which means the vertex would be at negative 1, 6. That would be this point right here. So in terms of answering all of these questions, we could say the parabola opens up with a minimum of 6. It's just taking things that we have done in other parts of the unit and applying it in a word problem. So, guys, hope you found the video helpful. If you need additional help, please see your teacher. Have a good day.